Now next topic is identity element of a binary operation and inverse of an element. Here I have written a definition, and on this definition I will explain this question. But before discussing a question and definition, let us understand this word identity element and inverse of an element for binary operation. I take very simple example. Say we know that 5 plus 0 is equal to 5 is equal to 0 plus 5. Minus 7 plus 0 is equal to minus 7 is equal to 0 plus minus 7. Root 3 plus 0 equal to root 3 equal to 0 plus root 3. For any real number 3 by 2, see 3 by 2 is any number, it's rational. 3 by 2 plus 0 is 3 by 2 is 0 plus 3 by 2. So say these numbers I am taking from set of real numbers. So these numbers are, we say A. A is any real. This is fixed. Say this is fixed. A plus 0 equal to number A remains unchanged equal to 0 plus A. This is true for every A belonging to R. Now look here. Say you can match with this statement. A star E is equal to A is equal to E star A. This symbol we use for binary operation, and we know that addition is also a binary operation. Addition is an operator we operate between two real numbers. So here this is addition. This is addition, and see value of E in this statement is 0. So this condition is satisfied in this case. So if this condition is satisfied, given a binary operation star on A, if there exists an element E in A such that for every A belonging to A star E is equal to A is equal to E star A, then E is called identity for binary operator. Now this words I am speaking by replacing this star by this plus addition. So say binary operation addition on set of real numbers. Here there exists 0. What is E? 0. Here there exists 0 such that A plus 0 is A equal to 0 plus A. So 0 is called identity for addition. We are changing A. See, this is change, but this is fixed. Identity is the element which is fixed. Every time we are changing this A is change, not E. E is fixed. This is fixed. These are change. So here E is fixed, means there exists E in given set A such that A star E is E star A. This can also be understood by one more operation of multiplication. See, we know that 4 into 1 is 4 equal to 1 into 4, minus 5 into 1 equal to minus 5 equal to 1 into 5 minus 5. 4 by 7 into 1 is equal to 4 by 7 is equal to 1 into 4 by 7. So this is A. A into 1 equal to A equal to 1 into A. Now see, here binary operator is multiplication. Binary operator is multiplication, and this is E. A star E equal to A equal to E star A. So what is E here? 1. In this discussion, E is 1. Here in this discussion, E was 0. So 0 is identity element for operation addition. Here 1 is identity element for operation multiplication. Multiplication is also binary operation. So you can match this statement. This is true for all A belonging to R. For all A belonging to R, this is true. We are changing A, not 1. So 1 is fixed. See, 1 is fixed. A is variable. So here in this examples also, this definition is matched. So this is the meaning of identity element. Now I am coming on inverse of an element. See, first of all, I am discussing for operation addition. See, here words are given binary operation star on A with the identity element E in A. If we can find B belongs to A such that A star B is E is equal to B star A, then B is called the inverse of A and denoted by A inverse. So A is said to be invertible with respect to star. Say, here for operation addition, identity is 0. Here identity exists. See, words are with the identity E in A. With identity E in A. So here there exists identity 0 in R. Now see, here suppose I take 5. I am taking 5. A is 5. A equal to 5. Operation is addition. So 5 plus something equal to. See what we want here. Here we want this type of statement. A star B is E is B star A. A star B is E is B star A. See here A is real. Star in this example is plus. B equal to, what is E? E is 0. B star is in this example plus A. So this statement is rewritten with value of E because we know E is 0. Now see, we know that 5 plus minus 5 is 0 equal to minus 5 plus 5. So value of A I have taken 5. A is 5. And look, B is minus 5. When this condition is satisfied, B is called inverse of A. denoted by A inverse. So if we use those symbols, then what we say, inverse, this means what? Inverse of A is B. This means what? Inverse of A is B. So we are matching this statement on this operation addition. Inverse of A is B. So here what we can say, inverse of 5 is minus 5. This symbol we use for binary operation. And in arithmetic, inverse of 5, if this is considered as binary operation, then we don't speak inverse, we speak opposite. A number opposite to 5 is minus 5. But to explain these symbols and these words, this definition, I am taking this very simple operator, operation addition. 7 plus something is 0, is something plus 7. Here A is 7. A is 7. I am putting A is 7. Now what should be B? If we fill in the blank, then B is minus 7. So this is satisfied. A star B is 0, is B star A. So here 7 inverse of 7 is minus 7. If we take any number here, 3 by 2 plus something equal to 0 equal to something plus 3 by 2. So something is minus 3 by 2. Something is minus 3 by 2. So here, if you choose any A, then whatever we get here, that is B. This is binary operator. This is E. So here we keep E fixed. This condition is satisfied. Every time this number must be fixed. With every selected A, if there exists B satisfying this condition, then B is said to be inverse of A. In this case, multiplication. See, I am putting similar statement. Here A, in this discussion, binary operation is multiplication. A into B equal to E. What is here E? 1 equal to B into A. So we know that 4 into something is 1 equal to something into 4. A star B is E equal to B star A. So what is B here? So B is 1 by 4. So what we say? Inverse of 4 is 1 by 4. Inverse of A is B. If I take 5 by 2, if we keep here 5 by 2, 5 by 2 into something equal to 1 equal to something into 5 by 2. So here something will be 2 by 5. So inverse of 5 by 2 is 2 by 5. So see, here I am changing A. This is fixed. 1 is fixed. Here E is fixed. E is 1. A star B is equal to E is equal to B star A. So for every A there exists B such that A star B is E is equal to B star A. So B is called inverse of A. So this number is inverse of this number. If sometimes, suppose if it happens that suppose 4 into something equal to, if you don't get 1, if there does not exist any number multiplying it with 4, we get identity. That means inverse of 4 does not exist. both sides. 4 into something is 1 and something into 4 is 1. So B is said to be existed if A star B is E is equal to B star A. So both sides, this condition should be satisfied. Then we say inverse of 4 is B. For existence of identity also, for all A, both sides A star A is A equal to E star A is A. Both sides condition should be satisfied. That means only verifying this part. If only this part is satisfied, it does not mean that 0 is identity. We have to verify also this part. So only satisfying this part does not mean that E is identity. We have to verify also this part. Similarly here, only satisfying this part does not mean that B is inverse of A. This part is also required. A star B is E and B star A is E. Then B is inverse of A. So this is the meaning of this definition. Now we are coming on this question which is based on this definition. This was simple explanation because you worked with simple binary operators, operation addition, operation multiplication, operation subtraction, operation division. These operators already you know. Intersection is also operator. Union is also operator. Intersection of two sets. Union of two sets. So see, these operators are operated on sets. Between two sets we use operation union or operation intersection. So there are so many operators. If these operators are operated between two objects, these are said to be binary operator or binary operation. Now here, say star be defined. This binary operation be defined on this set by A star B is AB into AB upon 10. So say here star be defined on set Q except 0, set of all rational numbers except 0. So this is defined by, it is defined by A star B equal to AB by 10. In the first part we are finding identity element. So method is, if E is identity, if E is the identity element for given binary operation, if E is identity for given binary operation, then we can find E belongs to A, then there exists E belongs to A. What is A here? Q minus 0. There exists E in this set such that now to find E only I am first of all we shall take this part. A star E equal to A. To find value of A in the method we will take this part. If E is identity, then there exists E in given set such that A star E is A. See, existence must be in this set only because binary operation is defined on this set. means this is working only on elements A and B which are belonging to this set. A and B both must be in this set, then this will work. So here, because this is working on A and E, E must be from same set. Now A star E is A. Now applying here formula, A star E is A. So what is A star E? So put here E. A star E is A into E upon 10 equal to A. A star E is A into E upon 10. B is replaced by E. Now see, here A and B, see A and B both are in this set. So no one is 0. A is non-zero rational number. Because A is non-zero rational number, we can divide this equation by A, because A is non-zero. So division is allowed. So E is 10. E is found. Now this value of E we have found from this part. Now it should satisfy this part also. For same value of E, E star A must be equal to A. So see, we verify this part for which E star A equal to E is 10 star A. I am putting E equal to 10 here, 10 star A. Now what is 10 star A? So 10 star A is 10 into A upon 10. So 10 into A upon 10, this is cancelled, so it is A. So see what we have obtained. E star A is A. E star A is A. So for this value of E, so for E equal to 10, A star E equal to A equal to E star A. This condition is satisfied for all A belonging to set of numbers, for all A belonging to set of rational numbers except 0. So this is satisfied. Therefore here we have obtained 10. It is identity for star. Therefore E equal to 10 is the identity for binary operation star. See again in this method, first of all take this part, A star E equal to A, find E, then take this part E star A, begin from E star A and derive that it is equal to A for value E equal to 10. So this is verification of other part, it is must. So if A star A is A and E star A is A, then E is identity. Because sometimes what happens, you are getting value of E beginning from this part, but if you substitute value of E in this part, then sometimes it may happen that E star A is not equal to A. A star E is A, but E star A is not equal to A. So in that case, E cannot be taken as identity. So that's why verification is required. Now, for inverse of an element, we suppose that inverse of A is B. Suppose that inverse of A is B. If inverse of A is B, then A star B is E. Then A star B is E. But already we are having now E. What is E? 10. So this will be used here. Now we are doing this procedure with identity element E. So put here E equal to 10. E is 10. Now A star B is 10. Now A star B is 10. Now what is A star B? A star B is AB by 10 equal to 10. So AB is 100. Therefore AB is 100. So B is 100 upon A. Beginning from this part, using here value of E, we have found value of B. But B is called inverse of A if this is also satisfied. So second part we have to verify. So for which, let me verify second part. B star A. B star A, that is BA by 10. B star A is BA by 10. Now here we keep value of B. So value of B is 100 upon A into A upon 10. See, A is cancelled. So what is it? 10. So B star A is 10. A star B is 10. For this value of B. So for B equal to, therefore for B equal to 100 upon A star B is 10 and B star A is also 10. For obtain identity element E, A star B is E and B star A is also E. So B is inverse of A. Therefore inverse of A is B. Therefore inverse of A is, what is B here? 100 by A. So this is true for all A. For all A, it is true for all A belonging to Q except 0. So every element of this set we can find inverse. As for example, say here, if you put A equal to 2, so 2 inverse is 100 by 2. So 100 by 2 is 50. If you put here 10 inverse, 10 inverse is 100 by 10 is 10. If you keep here 5 inverse is 100 by 5, that is 20. Like that. You can find inverse of any number. If you take here negative, suppose minus 20, inverse of minus 20, put here minus 20. So 100 upon minus 20 is minus 5. So this is way to find inverse. Let star be defined by A star B is A plus B minus 2 on Z, set of integers. So here numbers A and B it will be from Z. They are integers. Find identity for binary operation star and inverse of A if exist. Say, we know that to find identity, we will use this property. For every A, if there exists E satisfying this condition, then E is said to be identity. So here, say here, star B defined by A star B is A plus B minus 2. This is defined on Z. This binary operation is defined on Z. This is defined on Z. Now see, if E is the identity element for this binary operation star, then, or if suppose that E is the binary operation, E is the identity element for binary operation star, then to find E, first of all we are taking this part. A star E equal to A. A star is A, that means now A star E, so it is A plus E minus 2 equal to A. Replace B by E, so A star E is A plus E minus 2. Now here A can be cancelled, so E is 2. So this is obtained from this part. Now for this value of E equal to 2, is it true? That verification is required. So for which, for this value of E, let me check. E star A, E star A, that is 2 star A. 2 star A, that is 2 plus A minus 2. So it is 2 plus A minus 2. 2 star A is 2 plus A minus 2. So this 2 is cancelled. So what is it? A. So see, E star A is A. So therefore, for E equal to 2, for this value of E, A star E equal to A equal to E star A for all A belonging to Z. So therefore E equal to 2 is the identity for binary operation star. This is the method to find identity. Now for inverse we use this statement. For element A, if we can find B such that A star B is E is B star A, then B is said to be inverse of A. So here, if suppose that inverse of A is B, we suppose that inverse of A is B, therefore A star B is E. So A star B is E. Use this part of condition to find value of B. A star B is E, that means already here E exists. E is 2. If E does not exist, then there is no question of finding inverse. Continue procedure of finding inverse of any element if identity exists. Otherwise, don't show this procedure. No question of finding inverse. Existence of inverse is valid if E exists. Now A star B is 2. A star B is 2. Now A star B is A plus B minus 2 is 2. So what is B? So B is 4 minus A. This is B. Now let me check. We verify this part. For this value of B, is it true? For which? For which? B star A. B star A, that is B plus A minus 2. Now, what is B? B is 4 minus A plus A minus 2. So here A is cancelled. So what is obtained? 2. And 2 is E. So say this is verified. B star A is E. B star A is E. And A star B is E for this value of B. Therefore, for A belonging to Z, for A belonging to Z, there exists B equal to 4 minus A such that A star B equal to E equal to B star A. So condition is satisfied, therefore inverse of A is B, so inverse of A is 4 minus A. So here this was on Z. So what is the meaning of this statement? Okay, if I keep here 2, so what is 2 inverse? 2 inverse is 4 minus 2, that is 2. If I take here 5, 5 inverse. 5 inverse is 4 minus 5 is minus 1. If I take here minus 10, minus 10 inverse. So minus 10 inverse is 4 minus minus 10. 4 minus minus 10 is 14. For any number belonging to Z, its inverse is subtract this number from 4. So 4 minus 100, that is 96. So inverse of any number can be found by this formula. Let star be the binary operation on set of natural numbers n given by A star B is equal to LCM of A and B. Find the identity of star in n. Find inverse of an element if exists. Say here, binary operation is defined on set of natural numbers n by this formula. A star B is LCM of A and B. Say, formula is LCM of A and B. Now, if E is equal to, suppose if we take E equal to 1, then what happens? A star 1, A star 1 is LCM of A and 1. Now LCM of A and 1 is A. LCM of 5 and 1 is 5. LCM of 6 and 1 is 6. LCM of 7 and 1 is 7. Similarly, if we think about 1 star A, then LCM of 1 and A. So LCM of 1 and 7 is 7. LCM of 1 and 6 is 6. LCM of 1 and 100 is 100. List a common multiple of any number A and 1 is A. So therefore here A star 1 equal to A equal to 1 star A for all A belonging to N. For all natural numbers this is true. Therefore 1 is the identity for binary operation star. Now if inverse of B, if inverse of A is B, then A star B is equal to E is equal to B star A. This should be satisfied. Say here E is 1, so I am putting here 1. So that means LCM of A and B, LCM of A and B equal to 1 equal to LCM of B and A. Now think about this question. LCM of which number is 1? LCM of which two numbers is 1? If you say LCM of 2 and 3, so it is 6. If you say LCM of 4 and 8, so it is 8. LCM of 7 and 1, so it is 7. So there is only one option left, that LCM of 1 and 1 is only 1. No any other answer. This statement is true, but we know that LCM of 1 and 1 is only 1. No LCM of any other pair of such numbers is 1. LCM of only this pair is 1. So the statement is true for A equal to 1, B equal to 1. Therefore A star B equal to 1 equal to B star A is true for A equal to B equal to 1 only. So inverse of 1 is 1. Therefore inverse of only 1 exists, and inverse of 1 is 1. Now in this question, let star be the binary operation on N defined by A star B is HCF of A and B. Find inverse for this binary operation if exists. Say for inverse, first of all we have to find identity. So we do procedure for identity. Say here, on set of natural numbers N, A star B is defined. It is HCF of A and B. Now see, if E is the identity, then for all A belonging to N, we must have A star E equal to A equal to E star A. So we must have identity element E satisfying this condition. Now, does it exist? What is its value? To find its value, we use this part of property. So using this part of property, if we can find E, then this part we will verify. E star A equal to A, that will be verified later on, if E is found from this expression. Now A star E is A, that means HCF of A and E is A. Here this is fixed, this is constant, and this is any natural number. For any natural number A, E is fixed. Now see, here I am putting few statements. HCF of 5, HCF of 5 and 5 is 5. HCF of 5 and 5 is 5, or I say HCF of 5 and 10 is 5. HCF of 5 and 10 is 5, but HCF of 6 and 10 is not 6. HCF of 7 and 10 is not 7. Here you can see that HCF of A and 10 is A, HCF of 5 and 10 is 5. So if you want to take this number as E, then taking same value here, the statement is not true. We want this number fixed. If suppose if you take E equal to 5, so here in this case HCF of 5 and 5 is 5. HCF of A and E is A, but then HCF of 6 and 5 is not 6. HCF of 7 and 5 is not 7. So we cannot take E5, we cannot take E10. So here we don't have any constant E. From this statement it seems that E is 10. From this statement it seems that E is 5. E must be fixed, and for that same value of E, all statements must be also true. If you take E5, then everywhere keeping here 5, this number should be this A. Same number should be here. If you take E10, same number should be here. So here E fixed constant does not exist. So this statement, but this statement is not true for any fixed value of E. So therefore E does not exist, and if identity does not exist, that means inverse of any element does not exist. Say here you can also imagine another example. Suppose HCF of 4 and 6 is 2. HCF of 4 and 8 is 4. That means it is what? 4 star 8 is 4. So this is looking like E. A star E is A. But 4 star 12, HCF of 4 star 12 is also 4. 4 star 12 is also 4. HCF of 4 star 16, HCF of 4 and 16 is also 4. 4 star 16 is also 4. So here you can see that 4 star something is 4. Here we are getting value, but if this number is constant, then it can be taken as E. But you can see that here changing value. 16, if you keep 16, this is true. If you keep 8, this is true. If you keep here 4, this is true. E doesn't change its value. So no one can be taken as E. And if you take this number as E, then for same value, if you change this number, means if you take E equal to 16, considering this is true, but then for A equal to 16, 5 star 16 is not equal to 5. 6 star 16 is not equal to 6. So that's why here E does not exist. E must be fixed as it was there. See, 1 was fixed. Change here any number. LCM of 6 and 1 is 6. LCM of 7 and 1 is 7. LCM of 8 and 1 is 8. But here LCM of 2 and 2 is 2. LCM of, sorry, for this question, their word is a HCF. HCF of 4 and 4 is 4. But HCF of 5 and 4 is not 5. HCF of 6 and 4 is not 6. These number remains same. These numbers remain same. This must be fixed. No any such value of E. Putting that value fixed, changing this number, it becomes true. So here identity does not exist. Given a non-empty set X, consider the binary operation star, which is defined on P of X cross P of X to P of X, given by A star B is A intersection B. For all AB belonging to P of X, where P of X is the power set of X, so that X is the identity element for this operation and X is the only invertible element in power set of X with respect to star. Say in this question, Px is the power set of X. Say here P of X, this is power set of X. It means what? Means this is set of all subsets of X. Power set of X, that is set of all subsets of X. See, if A and B are in the power set of X, A and B are in power set of X, that means what? A and B are subsets of X. So this is a meaning of a power set. So because this topic was explained in class 11, here we are using, so once again revising meaning of power set of X. Now we are coming on binary operation. For every AB belonging to power set of X, Every AB belonging to power set of X, that means for every AB which are subset of X, A star B is defined as A intersection B. Intersection is here operator. Now, if E is the identity for this binary operator, say whenever we find identity, it is element from the same set on which binary operation is defined. Here this operation is defined on this set. What is it? It is power set of X. So E must be in power set of X. If E is in power set of X, that means E must be subset of X. So this element will be subset of X. So we should not use a small e. It is not a number. In case of number, we use small e. But because in this case, it is element of this set, hence it will be subset of X. So we use here capital E. If E is the identity for star, then A star E equal to A equal to E star A for all A belonging to power set of X, or for all A subset of X. For all A belonging to power set of X, that is for all A which are subsets of X. That is, this is true if and only if A intersection E. A star B is A intersection B. So A star E is A intersection E equal to A equal to E intersection A. Now see, from properties of set theory, this statement is true if here we replace E by X. If E is X, then above statement is true. That is, A intersection X equal to A is equal to X intersection A. X is the biggest set, A is its a subset. So A intersection X equal to X intersection A. So here E is A. Therefore, E equal to A, E equal to X is the identity. X is identity element. Now, to find inverse of any element if exists, if inverse of A is B, if inverse of A is B, then A star B should be equal to identity E equal to B star A. This is true if and only if A intersection B equal to, now what is E here? X. E is X. E equal to X is the identity element. So A intersection B is X equal to B intersection A. Now see, this is a universal set, biggest set. A and B are subsets, but because A and B are subsets of X, A and B are subsets of X, so this statement is true for only A and B if you both take x. This statement is true for A equal to x, B equal to x only, because A and B are subsets of x. That is, x intersection x equal to x equal to x intersection x is only the case which is true. So therefore inverse of x is x. Only inverse of x exists. Therefore only x is invertible. X is only invertible, and its inverse is x. Define a binary operation star on the set containing these 6 numbers as A star B is A plus B if A plus B is less than 6, and A plus B minus 6 if A plus B is more than or equal to 6. Show that 0 is the identity for this operation, and each element A non-zero of the set is invertible, with 6 minus A being the inverse of A. Say here this binary operation A star B, it is defined by this way: A plus B if A plus B is less than 6, and A plus B minus 6 if A plus B is more than or equal to 6, where A and B are numbers from this set, where this is defined on, let me say this is set A. Now first of all, procedure for identity. If E is the identity for this binary operation, then for all A belonging to this set A star E is A. A star E is A, so A star E, that is either this will happen or this will happen. So A plus E equal to A, or if I use this formula, then it will be A plus E minus 6 equal to A. A star E is A plus E or A plus E minus 6. We check both the possibilities. So this means here E equal to 0, this is cancelled, or here A cancel, so here E equal to 6. But see, identity is the element which must be belonging to A. You can see that this number does not belonging to A, but E equal to 6 does not belong to A, so E is not equal to 6. So E equal to 0 is acceptable. Therefore E equal to 0 can be taken. And for this number, let me verify second part. This is obtained from A star E equal to A. Now we check for this value of E star A equal to A. E star A, this we want A, E star A is 0 star A. Now 0 star A, so 0 star A, that means these are numbers 0 and A, 0 and A. Now A is in this set, so 0 plus A, sum of these numbers, it will be maximum 5. This will be maximum 5, so it will not be more than or equal to 6. 0 plus A, if you add 0 and A, then this sum is equal to A. This is equal to A, and it belongs to this set. So this value is maximum 5. Maximum 5 means less than 6. So we use this formula. So 0 star A is 0 plus A, because 0 plus A is less than 6. It is equal to A. We don't use this formula because sum of these two numbers is not more than 6. So therefore, for E equal to 0, is A star E equal to A equal to A star A. So this is the identity for binary operation star. Now, so now I think it is clear that why here we are using only this formula for 0 star A. 0 star A, I have used 0 plus A, not 0 plus A minus 6, because 0 plus A is A. 0 plus A is A, and value of A is less than 6, because A is from this set, its maximum value is 5, so less than 6. That's why this is used. Now for inverse, if inverse of A is B, then A star B equal to E. A star B is E, that is A star B equal to 0, because E is 0. Now this value of E, that will be used here in next part of finding inverse. Now A star B, there are two possibilities, this number or this number. So that means A plus B equal to 0 or A plus B minus 6 equal to 0. That means B is minus A, or this means B is 6 minus A. So here B equal to minus A, this is possible only if A is 0 and B is 0. If both are 0, A and B both are 0, then this is possible, because A and B are taken from this set, and sum of A and B 0 is possible if A is 0 and B is 0. This is possible. This is possible if A equal to B equal to 0. So this means here what is proved, that 0 inverse is 0. B is inverse of A. So inverse of A is B, that means 0 inverse is 0. So inverse of 0 is 0. That part here it is clear. Now on this side, if B is 6 minus A, then now for this number we verify B star A equal to E. See, this is derived from A star B equal to E. Now we verify this value for B star A equal to E. So for which B star A that is 6 minus A star A. Now sum of these numbers is 6, and if sum of numbers is 6 equal to 6, then we use this formula. So we are using this formula. A star B is A plus B minus 6. So this is cancelled. So this is 0. Therefore, for B equal to 6 minus A star B is E, A star B is E, and B star A is also E. So for both the cases we are getting identity. Therefore B is inverse of A, where A is non-zero element, because here if A is 0 then its inverse is 0, but if A is non-zero its inverse is 6 minus A. So result is true.